It looks like I'm starting to get the hang of this. It used to take me about 5 minutes or so to get going on a stream, and now it's only taking a minute or two, which is great. Hi, welcome back to my stream. I am working my way through the Roguelike tutorial in Rust. It uses the specs ECS as the back end, and we have gone through quite a bit of this tutorial. If we take a look here at the table of contents, we can see we've gone through all of section 1, which is Hello Rust. Well, it's titled Hello Rust, and we generate map, we can generate monsters, we can deal damage and take damage. We've got some sort of a user interface. We did work on saving and loading, although I'm doing all browser-based stuff in WASM just to make the experience for me a little bit easier. And we added difficulty levels, so you can go down dungeon levels now. You can't go back up yet, but maybe that's coming soon. And then we have equipment, so we have 2 different weapons and 2 different shields. No armor yet, but armor seems like it's pretty straightforward to add. So yesterday we did 2 streams, actually. I did a stream early in the morning for me. I'm on Eastern time, Eastern US time. I did a stream which finished up the equipment, and we created an end screen. Oh, this is a different thing. Particle components. Okay, so then I started a new stream later in the afternoon my time, and we did the bloodstains thing. And then we did a little coding of our own outside of the main tutorial where we were making sure that the fireball scroller is something that attacked items. Let's see. I don't have a shield. I don't have a magic missile. Let's see. That's the confusion scroll. What was happening was we cast fireball scroll, and then the magic missile scroll, for example, would report that it took damage. So we have these fancy new walls, right? If I do this, yeah, that works pretty well. This is something I saw in a, oops. And, I managed to survive. Okay. So here's a fireball scroll. And it used to be the case that if you use the fireball scroll with a non-mob as in range, let me try it. And then it would report that thing took damage. And now I'm saying I use the fireball scroll, but it fizzles. And that now that I'd used that seems like a bug too, because it's going to report it fizzles on every entity. So let's fix that. So if I just do a refresh, is that fireball? That's confusion. It's hard for me to tell the difference between the pink. Oh, that's clearly orange. So if I say use the fireball scroll with these 3 daggers in range, it's going to fizzle 3 times, right? Yeah. I should say it fizzles against the. Let's take a look at what we changed here. Yeah, so I just added, but it fizzles. And we should grab the mob name too, right? Yeah, we can do that. Okay, so grab the mob name and against, maybe we just don't report anything, right? But for now, we'll put this in here, item name, and see what that looks like. All right, so let's refresh until we get a confusion scroll. That looks like one. It is. Okay, and now I'll cast it against these guys down here. Oh, and now it doesn't report anything. All right, well, maybe that's better. I don't know. Let's see, what did I mess up? Oh, it probably panicked, right? Although, no, I don't see any messages down here because this didn't work. No. Go away. No, Oh, maybe mob name didn't work? Yeah, okay, so it didn't completely die. The game's still running. Names get mob unwrap. Why didn't it report that? Let's see if running it in here. Well, let's set the backtrace. If that'll make a difference. Oh, and the other thing we did yesterday was we cleaned up the build a little bit so it runs a little faster for WASM, because the WASM build does not need a save load system. And we had commented out the save system, but somehow I missed commenting out the load system. Okay, there's a confusion scroll right there. Let's grab it. Let's cast it. Hit it on this potion. Oh. Oh, it fizzles against fireballs. Oops. Okay, so maybe I just messed up my... It's not item name, it's mob name. Okay. Yeah, so we were building in around 15 seconds. Now commenting out the load system. Now we can build in 7 to 8 seconds. 78 seconds. All right, so let's refresh until we get a fireball scroll. And let's cast it in here. Yeah, use fireball with physical against confusion. I hit myself. It fizzles against health potion and it fizzles again. Okay, that's good enough. Clippy shouldn't care. We didn't do anything really fancy. Git add source, git commit, report what the spell is fizzling out against. Okay. All right, so let's continue with this. So we did, like I said, we did the blood stains. We did the nicer walls, and so now we're on particle effects. So let's close that up. So there's no real visual feedback for your actions. You hit something and either it goes away or it doesn't. Bloodstains give a good impression of what previously happened in a location, but it would be nice to give some sort of instant reaction to your actions. These need to be fast, non-blocking, and not too intrusive. Particles are a good fit for this, so we'll implement a simple ASCII CP37 particle system. Okay. It reminds me of the song Particle Man. Okay, as usual, we'll start out by only by thinking what a particle is. Typically, it has a position, something to render, and a lifetime, so it goes away. We've already written 2 out of those 3. We've already written 2 out of 3 of those. So let's go ahead and create a particle lifetime component in components RS. All right. And this gets serialized and deserialized. Actually, we can just use convert save load because it has a... It's not an empty struct. Pub lifetime ms f32, like that. Have to register it in the usual places, main and save load. Particle lifetime, and we're gonna add it to save load system. Particle lifetime, and we'll do the same thing. Oops. I just might, oops. I just want to make sure that I think they have to be in the same order, right? Defense bonus, wants to remove, particle lifetime, serialization helper. Okay. we'll make a new file, particle systems. I think this is the first new file in a while, right? And what are we doing to it? It won't be a regular system. Okay, that's interesting. It won't be a regular system because we need access to the RLTK context object. But it will have to provide services to other systems. Okay. The first thing to support is making particles vanish after their lifetime. So we start with the following in particle system. So what is this doing? Cull dead particles. So we look at particle lifetime. We grab entities. Any entity that has a particle. We subtract the frame time for that context from the lifetime of the particle. And if we've gone below 0, we just delete the particle. Okay. And then we iterate. And as we iterate, we delete. RLTK and particle lifetime. We have a mutable reference to the world because we're going to we're changing data and we're possibly removing RLTK. And we create a new vector of the entities that we're going to destroy. Sorry, the vector of entities that we're going to remove. Yeah. Okay, so particles must be entities then, right? All right, and we have to go for a subcontext to make sure that the borrow checker doesn't get worried. ECS write storage, particle lifetime. So because we're going for write storage, we know that these are components. So all the particles are just components. And we're grabbing all the entities. And for every entity, oops, and with the particle attached to it, and we're going to loop over those and we're going to subtract the frame time. And if we've aged out the particle, then we will add it to our, and we're going to add the entity, not the particle, to our list of dead particles. So this is just finding any entity that has a dead particle on it. It doesn't, Oh, okay. So maybe the entities are the particles. Okay, so we're not attaching these particles to like the player or the mobs or items or anything like that. What we're doing was we are creating new entities that are particles and have a particle lifetime component. That must be it, because look at the next loop. Iter, right? We're going to iterate over all those dead particles and we're going to delete the entities. So we don't want to delete the mobs, right? We don't want to delete the player. We're just deleting the particle. If I say particle too many more times, it's not going to be a word anymore for me. Okay, so that's this code here. That'll clear out any, well, it times out any particles that died as a result of this frame time passing. All right, then we modify the render loop in main to call it. Okay, and I moved that over to game state. Oops. Right. So right after CLS, we're going to call particle system, call dead particles. and we probably need to import it, right? No, I do create star, so maybe that will include it if we add it to the mod, right? Pub mod particle system pub use particle system : star. That might mean we don't need to qualify it with particle system at the front. Let's see if it builds. No RLTK in root. Oh, that's supposed to come from RLTK, not RLTK, right? I mean, not from our thing, right? Use RLTK, RLTK. Why would we get that from super? Okay. Immutable borrow happens here, and a mutable borrow occurs here. So what do we do wrong? I must have missed something here. Let mute particles, entities. Oh, yeah, this is supposed to be inside, outside the thing, like this, right? Yep. Okay, so that builds, which means let me try removing this as I am importing the whole thing. So, oops. And see if that builds. It's only another 7 seconds of my life, right? Okay, so that works. That means that, oh, let's see if Clippy's happy. Okay, so now we still haven't done anything, right? Because we're not generating any of these entities. So I guess that's going to come later, but we're creating a new particle builder. So let's extend particle system RS to offer a builder system. You obtain a particle builder and add requests to it, and then create particles as a batch together. Offer the particle system as a resource, so it's available anywhere. This avoids having to add much intrusive code into each system, and lets us handle the particle spawning as a single fast batch. Okay? Our basic particle builder looks like this. We haven't done anything to actually add any particles yet, but this provides the requester service. All right. So let's take a look at what this is doing. In our particle system, we'll add a new struct with a particle request. We have an XY component. We have a foreground and a background. We'll have to add that glyph, RLTK, font, jar type, and lifetime F32. Right? And so let's go up here and add RGB. Okay, and then we have pub struct particle builder requests vec particle request, and then we implement particle builder. What? Allow Clippy new without default. Is that explained? No. Clippy new without default. Let's find out what the hell that is. Clippy new without default. Clippy lints. Ooh, that's bright. New without default. What to do? Checks for types with a fn new self and no implementation of default. Users might expect to be able to use default. To fix, add a default implementation. Added in pre 129. And it's a warning. That's different. Okay. I mean, we're definitely doing a new to self, right? How do we handle it elsewhere? Because there are other places where we do a new, right? A new to self. Let's look for new followed by that. Oh, a new empty followed by self. Oh yeah, so yeah, we do it here in random table. Let's take a look at random table because I don't remember adding that before. Yeah, there's a new here, but we don't have that warning. Oh, okay, so there's this derived default thing. Maybe that's all we need to do. Let's try it. Derive default. Gotta spell derive correctly though. Right? And maybe that'll allow us to avoid that pub fun new particle builder. And with the new vec. That. And then we create a request. RGB, background, RGB, glyph. I was just thinking maybe I could just copy and paste this and put everything together because it looks like it's just the same thing. RLTK, font, char, type, life, but I've already typed in most of it, 32. And that just pushes self requests.push, a brand new particle request of like this, X, Y, foreground, background, glyph, and lifetime. Right? I'm sure this will get reformatted by Clippy, but I'm just going to do that. Sorry, by cargo format, but I'll do that. All right. So that gives us a particle request builder. Now it's not used anywhere. Let's see if it builds. It should complain that it's not used, right? Oop, font char type. That's on line 42. Every so often that has to happen, right? Particle builder requests help a new field. Oh, I mistyped the definition. Like that. Yeah. Oh, and I mistyped it on line 43 as well. Wow. My fingers really want to do QEU instead of QUE. Yeah, so now it's saying these fields aren't used, but it compiled. And Clippy should also complain that it doesn't, those aren't used. But we're not getting the default warning. So what I'm going to do is I'm going to comment out that derived default, and just to see if that actually is the thing that's doing the thing. Yeah, look at that. You should consider adding a default implementation. Okay, so that's what it was. You can allow Clippy new without default, or I'm surprised it doesn't just suggest what we did. Maybe what we did is not idiomatic Rust, but why would it exist? Okay, so that's fine. We'll leave it there. I'm happy with that. All right. So in main.rs, we'll turn the particle builder, into a resource. Right? So we'll just create a new particle builder. Right? So where should we insert that? I don't think it matters. ECS insert particle system, particle builder new. Right? And then we'll go back to particle system and build an actual system to spawn particles. Okay. So we go back here, and now down here. Now that we've got a particle builder and a call-dead particles function, we can actually start making particles. I would have done it the other way around. You know, start by making the particles and say, okay, now what do we want to do with them? Impl. But that's okay. Like I said, we got there in the end. Ooh, Togglebit, thank you very much for the raid. Hope you had a good stream. For particle spawn system. So what we've done for the people who just arrived, we've gone through all of section 1 in this roguelike tutorial, and now we're working on the stretch goals. We did the nicer walls, so you can see these nice walls around here. We have bloodstains showing up now, which colors the tile background red when there's combat on them, and we're working on particle effects. So I'm looking forward to seeing particles. And we've done a lot of writing, but we haven't done any running yet because we haven't gotten to the point where we can spawn particles, and that's what we're doing now. And this type complexity, the way I work around type complexity is by just creating a separate type instead of doing the Clippy allow. Particle spawn data. It's okay. And it's just entities. And then a bunch of write storage. Yeah, link to the tutorial is right up here. I can copy the chapter that I'm on now and paste it in the chat. Oh yeah, thanks Atlas. Atlas got there before me. And thank you for the follows. SureShack55 and I am Ferris, or Imfaris. Write storage, position. The tutorial is actually pretty long. Whoops, that's specs. Sorry for the blinding. Yeah, so we just scratching the surface here. We did basically a bunch of Rust stuff here, learning Rust, learning how ECS works, and learning how the RLTK, the toolkit works. You can see there's a lot of stuff here we're going to go through. And at some point, I'm going to switch off to do Advent of Code once that starts up. And then we'll come back to that after Advent of Code. Come back to this after Advent of Code is over. So we have 3 write storages. Renderable, particle lifetime, and then a write expect, particle builder. Yeah, it has been a lot of fun, Atlas. I've been enjoying it so far, and it actually shows you how you can set it up so it runs in a browser in WASM. So there's a bloodstain right there. That was from me. I attacked myself to test something. But you can see it's just running in a browser. It's got a little, that uses console log for the initial stuff, but then eventually, you get to do GUI stuff here, like showing an inventory and showing what you're wearing and stuff like that. It's been quite a learning experience, and I knew a little Rust going into this, but I've learned a lot more just by going through this. Particle spawn data. Yeah, I think that's the way it works. All right, and then we write the run function. So in order to spawn, let me close that out. In order to spawn a particle, crafting interpreters sounds like deep magic to me. Can you share a link to that? That would be interesting to go through as well. Let's see. Okay, so particle spawn system will loop over every entity that has a position, a renderable particle on a particle builder. No, it'll loop over all requests, right? And it will insert a new position and and renderable for the particles. Okay. Thank you. Let me see if I can copy that link and put it right over here. Oh, there's no dark mode. Okay. Bytecode virtual machine. Oh, wow. This looks really interesting. This is really interesting. How far along are you on it? All right, we got the system data, and then we just break it down using the decomposition. Positions, renderables, particles, and the particle builder. Starting chapter 2, and you've been procrastinating big time? Yeah. Yeah, I know that feeling very well. I've been going through this particular tutorial for over a month now, maybe a month and a half. I used to only stream a half hour or an hour a day, but it's been slowly growing as I've been getting into it. So let's iterate over all the particles, and we create a brand new entity for the particle. We're going to insert a position for it. I'm not sure why you can't use the entity build, you know, with the width and all that kind of stuff, but maybe there's something special inside a system that you need to do it this way. X new particle X and Y new particle Y. Expect. Unable to insert position. I'm going to guess that's what that says. Positino. Did I miss a paren? Yeah. Okay. And then renderables, same thing. Insert. For the new entity, we're going to add a renderable. Oops, this doesn't get this, right? Yeah. Okay. That's what I messed up. There we go. Renderable goes that. We get the foreground, new particle foreground, the background, new particle .bg, and then the glyph, right? Oh, and render order too. Okay, glyph, new particle glyph, and it takes a render order of 0. So I guess it just means it renders on top of everything. And then we need an expect, right? Expect unable to insert renderable. And then finally we have to insert into the particles itself. Insert P the particle lifetime. Lifetime ms is equal to the new particle lifetime. And then we're done with that loop, and then we clear the particle builder, right? Particle builder requests clear. So that's the system, so we haven't done anything with the particle builder yet, but what looks like what's going to happen is we're going to call into the request thing, which adds a particle request to the list. And then when we run this system, it'll pull from that list and generate all the particles that are in the request list. Right? So then here's where we're going to run the system. This is in game state. Somewhere down here, yep. So, and this is just particles. Particle spawn system. And particles run now self ECS. And I think I can get away with just doing it this way because I did the import earlier. Right? And I'm just pulling in everything from the crate. So this should compile, even though we're not using the particle. Ooh, okay, so we need to add position to the particle system. Anything else? Oh yeah, renderable too. Okay. So we need position and renderable. And is that the only bug? Nope. Oh, yeah, so we're not using it yet. Unused result. Oh, I'm not doing an expect on that guy. I left the expect off of him. So that's on line 85. Expect unable to insert particle. Right? And now we're going to get to the finally, now that we've set up all the infrastructure, we can actually spawn some particles. Why am I not using cargo? I am. What I did was I created a build script because it's a multi-step process. And by multi, I mean 2 to build. So I do a cargo build for WASM. And then I run WASM bindgen to generate the actual WASM code for the browser. And if you look in the WASM directory, the index is what I refresh, and then it loads behind the scenes. Let me just cat that. What that does is it loads the JavaScript that is the interface, and then it loads the WASM file here. Might want to look into hooking the output of cargo check to your quick fix list, perhaps using a COC plugin. Okay, so I'm still new at Rust, and I don't know. I saw that Togglebit uses this :cargo commands in his NeoVim. I have not set that up. I haven't looked into that. Me and NeoVim plugins don't get along, probably because I don't know what I'm doing. But that would be neat if I could speed up my workflow by just pulling in all the errors and then just looking at them simultaneously. I could put that in a makefile and use make inside of Vim. Okay. And now there's a quick fix list. I will look into that off stream. Thank you for the suggestion. I know that if I started looking into it now, I would just be fumbling and bumbling around for the rest of the stream. But if I look into it off stream, then I will take a look. Togglebit has his Rust NeoVim config on GitHub. Oh, okay, cool. I'll take a look at that. Then maybe I'll just steal his. Thank you. All right, so let's spawn some particles. We're going to open up Melee Combat System and we'll add Particle Builder. Okay. Source lib Melee. Thanks, Suisse. Oh, I got a couple more follows. Thank you, Atlas, for following. Massly, ATM, Miskatrol, Pyro 240, and Zelda Fan 256. Zelda Fan. I've just been watching Lorgon 111. I don't know if you guys know him. He made a brand new tracker for the Zelda randomizer, and he's been showing that off on YouTube. It's pretty interesting to see. I don't play Zelda myself, but it was neat to see how he did that and how the tracker works and all that. Builder. If you only want a very basic setup without fancy language service. Yeah, I tried NeoVim with the Rust Analyzer plugin, and it spawns so much stuff inside my Vim window. Sometimes it's hard to read because of red on light red kind of error messages, and I get frustrated when I can't see what I'm typing because Rust Analyzer is in my way. All right, so we have all of these already, right? Entities, game log, monster melee. We're just adding particle builder and position to the bottom of these, right? Right, expect. And read storage. So the way specs works is that anything with the storage are components, and anything with expect is a resource. That's something I kind of slowly glommed onto over time. But Togglebit was suggesting that I take a look at alternate ECS libraries, and maybe once I'm done with this project, I will take a look at those. Cargo check compiles your package without generating any code. Okay, yeah, that would definitely be a lot handier, right? I run Clippy, and Clippy is a lot faster than compiling it. Okay, thanks, ModProg. Yeah, if he's got that to disable all the crap that gets thrown around on the screen, that would be really handy. I will take a look at that, and I will. What was it? The quick fix list. Yeah, that seems like the most interesting workflow speeder upper. Mute particle builder and positions. Okay. Storage expect an ECS convention. I don't know. It's the way specs. This is the very first ECS system I've ever used, and the way you pull out stuff. Oops, I didn't mean to hit G. I meant to hit that. The way you pull stuff out of the way you query the ECS is by creating a giant type, and then running join on the types you're interested in. Different ECS libraries work different ways with queries and setting things up differently. I don't know if they use the same terminology as expect and join and storage, but I'm definitely going to start looking into those as soon as, like I said, as soon as I'm done with this tutorial. I'm going to take a look at those and see how they differ. All right, so now we're going to add a request for damage. Okay. And we're going to add an orange and black particle with this double exclamation point and 200 milliseconds, if I'm reading that correctly. So before we calculate damage, which is where? It's here. It's slightly reformatted, thanks to Clippy. Okay, thanks, Atlas. I'll look at that. H quick fix. All right, so let's pull the position out of wants melee and then insert a new request for a particle. Right, and then this stays the same. This line is the same. They're just using that to show if let some pause. I'm going to slightly refactor this on the fly here. Get wants melee target, then particle builder request X and Y position, RLTK, RGB named. This is very verbose, RLTK orange, and I'm just going to copy that and change that to black. And then, right, and then RLTK to CP437, and I don't know how to type this, so I'm going to copy paste it, and then 200.0, right? Cargo format's going to reformat that anyway. Okay, so we're actually now creating a particle. So we did all of that, and we're not doing something. Oh, I forgot the ampersand, and I need to add position. Okay. Position. And where's the ampersand missing here? Right there. Still not good. Okay. Oh, I probably... what did I miss? I'm going too fast, right? Yeah, I forgot to add it here. And positions. All right. Oh, it's a little bit better. What's this complaining about? Method cannot be called on this due to unsatisfied trait bounds. Does not satisfy join. That's okay. I must have typoed something somewhere, right? Write expect, read storage. Those are the only two things there. We added mute particle builder and positions there. And then, oh, I wasn't supposed to add that here. Duh. That's what I did wrong. This is not supposed to be here. Okay. Yeah, okay, that's working. All right, and if we refresh this, and now we should be able to attack and see a very brief particle, maybe? If we can get attacked. Can we get attacked, please? There we go. So, oh, look at that. Did you see that? It happened really quickly. But you can see the double orange exclamation point as I'm getting murdered. And if I attack back on the goblin, yeah, look at that. Okay, so that worked. Nice, yeah, definitely nice. Goblin is dead and looks like I'm dead as well, maybe? Oh no, I moved down here. Okay, I was looking up there. That's a blood stain. All right, so let's see if Clippy's happy. So what did we do? We added a particle lifetime. We have something that calls the dead particles, just running the system to generate particles. If we, oh yeah, it stretched this out. If we cause damage, then we get a particle on the damage. And that's it. That's pretty small change, and we're getting a neat little effect there. Oh, git status. I think we have a new file. Yeah, git add source, git commit -m, create and show particles on damage. Let's push that up there. And this is my repo on GitHub. If anybody wants to take a look at it, although I think a lot of other people have done this same tutorial, so nice with the double exclamation part. Thanks, Alice. All right, so what's next? Adding effects to item use. Oh geez, look at this. It'd be great to add similar effects to item use, so let's do it. In inventory system, we'll expand the item use system introduction to include the particle builder. Okay. Where's the item use system? Down here. So we're adding, yeah, we're just adding the same thing we did to the melee system. Right, expect with particle builder and read storage a position. All right, and then we have to add those here and positions. Right? Okay, and then we'll start by showing a heart when you drink a healing potion. So in the healing section, we have this, and then we'll just add a new particle, okay? Where's the healing section? There we are. So we'll just do this again. If let sum position equals position, particle builder, pos x, pos y, RLTK, RGB, named RLTK green and black. And what are we doing? Putting in this heart. I'll just grab this whole thing. I like typing the code in myself when I'm doing tutorials because it helps get it into my brain, but once in a while I'll just cheat. Looks like we're going to be doing this for several things. We've got a magenta question mark for confusion. All right, let's just copy these lines. And where's confusion? Right down here. And it's a question mark instead of a heart. And it's magenta. And then we should also include a particle to indicate damage was inflicted. Did we already do damage? Oh, this is magic damage, right? So we're going to do red black with another double equal sign. Okay. So that's this. And we'll put that here. And this is red and the double equal sign. Like that. And lastly, if an effect hits a whole area, for example, fireball, it would be good to indicate what the area is. In the targeting section of the system, we add this. And this is just orange, black, and this sort of a gray splodge thing. So that's up near the top, right, where we generate, right, targets push mob, that's right here. Oh, we want it in blast tiles. So let's put that there. And then it's orange. And the character is this thing, whatever this is. I don't know what it's called. Copy, paste. Okay. That wasn't too hard, was it? If you cargo run your project now, you'll see various visual effects firing. All right. Will it build? I probably forgot to include, yeah. What did I forget? I think, oh, there's particle builder. Position should already exist, but this thing is not found in the scope. Oh. No. Oh yeah, these are mobs and this is target. I just copied and pasted blindly. Okay. Let's fix all those. Particle builder. So that's the first one. This is not pos X and pos Y, but what? Tile IDX. X and tile IDXY. Okay. And then for the next particle builder is down here. Do we have that? This is the healer one. Oh, it's not this. Positions get target. That's what that was. And then down here, right, instead of this, it's positions get mob. I don't see mob here. Oh yeah, there's mob. Okay, and then for the next one, it's also mob. There. Okay, let's see if that builds. Nope. Oh, I forgot to include particle builder. And then what was the other thing? It was saying not found in the scope. Tile IDX. Isn't that what this is? Yeah. Tile content IDX. Okay, let's take a look. I just typed it in without even thinking about it. Oh, tile XY. Tile XY. So I think that's a typo in the tutorial, right? We're getting closer. For some reason, we're not getting this. Oh, I used capital P. Pause like that. I did. There we go. Okay. Yeah, it's building. All right. Well, let's try a fireball, shall we? Oh, Rage CPP, thanks for the follow. All right, so that's not a fireball. There we go. There's a fireball. Who can we attack with a fireball? Oh, we just need to cast it, right? We just want to see what the particle effects are. So, oh, look at that. That happened so fast, though. I got to do it again. Yeah. Okay. That is pretty cool, I have to admit. The first roguelike I ever played was Lorne. Actually, that's a lie. The first roguelike I ever played was on a Commodore PET. So that goes even way, way further back. Thanks, Atlas. I wish I could take credit for the code, but I'm just doing what they're telling me. But I'm learning, right? That's the idea. Is we're learning how this stuff gets done. And then finally we have adding an indicator, and then we'll just finish out the chapter that way. Adding an indicator for missing a turn due to confusion. All right, so let's see if Clippy's happy. And git add source, git commit, add particle effects for potions and magic, I guess. All right, and that should show up right here. There we go. Okay. So let us finish up this. Lastly, we'll repeat the confused effect on monsters when it is their turn and they skip due to being confused. This should make it less confusing as to why they stand around. Okay. I think that was a deliberate pun. Monster AI system. So what we're going to do, we're going to modify the system header to request the appropriate helper. Oh, system data, I think they meant to say. All right, so all we need is particle builder. Right, and then we can include it here. And then we do need to destructure it, right? Right, and then we're going to do the request. So if after canact is false, we'll say particle builder request pause X, pause Y, RLTK, RGB named, RLTK magenta. Copy paste, black, and then we're going to do the comma, RLTK to CP437, question mark, and 200, right? Like that. And that's all we're going to do. And it looks like there's going to be a question mark for each turn that the monster is confused, the mob. Oh, I thought I added that. Did I just... Yeah, particle builder. Particle builder right there. Particle builder there. What did I miss? Oh, what I missed was typing it correctly. B-U-I-L-D-E-R. There we go. And finally, all right, let's get a confusion scroll. I don't think those are confusion. That's a magic missile. Is it this one? Yeah, that's confusion. Okay, so let's grab confusion and go find a mob to confuse. No mobs there. I should add a, I mentioned this yesterday, I should add a telepathy scroll or something. Oh, okay, so we're going to cast confusion on this guy here. And now we'll watch him as we step away. Oh yeah, look at that. Question mark, question mark, question mark. And then he follows me. Nice. Okay. So that's that. Let's see if Clippy's happy. It is. take a look at what we changed. Yeah, no, this has been a fun tutorial atlas, definitely. Mostly because I get to play a little bit of a game while I'm between learnings, right? All right, so that was really easy, right? All we did was add a request for a question mark to show up for 200 milliseconds every turn that a mob cannot act. So, pretty simple. Git add source, git commit, show confusion effects each turn for mobs. And with that, I think we're going to call it a stream. Let me see if there's anybody out there who's online. We have enough people here that we might be able to raid somebody. And nope, the only one I see here is MST3K. So I guess there's nobody to raid unless you have a suggestion. I'm going to call it a stream. So on Monday, I will be working on whatever's next, which is adding a hunger clock and food. All right, that's coming next time. Meanwhile, thanks everybody very much for watching. I hope you enjoyed the stream, and I will see you next time. Take care.